Unit 6, Day 8, the Rational Zero Theorem continued. This is Mr. McGough up in R12. I'm going to be going over today's notes with you. So first, we have a little bit of a review. We're going to solve the equation 5 times the quantity x plus 1 squared equals 120. So the first thing we need to do is divide both sides by 5. To get rid of that common factor, so we have x plus 1 squared equals 24. We could take the square root of each side. Instead of multiplying everything out and then finding roots, we'll just divide both sides by, take the square root of each side. Square root of x plus 1 squared is x plus 1. The square root of 24, well, 24 is 2 times 6. So we can take out a 2, and we have radical 6. We then need to solve for x by subtracting 1 from each side. So x equals, by the way, square roots are positive or negative. So it's negative 1 plus or minus 2 times the square root of 6, which is letter C. Finding possible rational zeros. Again, number 2, we're going to have to factor this. So we have negative 30 and 8. We need two numbers that multiply together to make negative 30, but add together to make positive 8. If it's factorable. The other option would be it's not factorable, in which case we would do negative 8, negative b, plus or minus the square root of b squared, 64, minus 4 times 2 times negative 15 becomes positive 120. All divided by 2 times a, which is 2, so we're over 4. 64 plus 120 is 184. There is no perfect square root of 184, so again, you would find those factors you can take out. 2 times 92, and then 92 is 2 times 48, etc. You'd work your way down through and simplify. Moving on to number 1, the new work. Synthetic division to find all zeros of the function. First, we want to make sure that all of our powers are accounted for. X to the third, second, first, x to the 0. So then we'll write this as 1, negative 2, negative 11, and positive 12. Now, before we can decide what we're going to put over on the left, we have to think about what the possible zeros are. As we discussed in day 7 lesson, we're going to take the 12 and find all of its factors. Its factors are 1, 2, 3, 4, 6, and 12. And of course, those can all be either positive or negative. Our leading coefficient is 1. Its factors are either positive or negative 1. So we're looking for P over Q. All of these are my P's. Both of these are my Q's. So my possible factors are going to be plus or minus 1, 2, 3, 4, 6, or 12. So we'll think it through. I've already done a couple of dry runs on this, and I know that 4 is the one that works. And on the next problem, I'll go through a couple of dry runs of the ones that didn't work for me, but we'll do this one first. So I bring down my 1. 4 times 1 is 4. Negative 2 plus 4 is 2. 2 times 4 is 8. Negative 11 plus 8 is negative 3. 4 times negative 3 is negative 12. No remainder. So 4 is a root, a 0. Now I need to find the rest. Well, what do I have left? I have x squared plus 2x minus 3. And this was times x minus 4. So now we're going to factor this part, which becomes x plus 3 times x minus 1, and then we still have that x minus 4. To find all of the zeros, we're going to set this equal to 0. The zero product property tells me if any one of these roots, any one of these factors is 0, then that's my root. So x minus 4 equals 0, x must equal 4 to make that equal to 0. x plus 3, x must be negative 3. X minus 1, x must be positive 1. So my 3 real zeros for the function are at x equals 4, negative 3, and 1. Problem number 2. Clean up from problem number 1. So I have some room here. So problem number 2. I'm going to do the same process. And when I do, I'm taking a look at all of my factors for positive 3, which are positive and negative 1 or 3, and all of my possible factors for 4, which are plus or minus 1, 2, and 4. So when I take a look at those, these are my p's, these are my q's. As fractions, it's going to be plus or minus 1 over 1, 1 over 2, 1 over 4, 3 over 1, 3 over 2, or 3 over 4. All those are positive or negative. So for me, I think that I would like to start with whole numbers before I get digging into the fractions. So let's try positive 1, and then positive 3, or positive 3, positive 1, we'll try negative 3, and if we have to, we'll go to negative 1. So all my powers are accounted for, 3, 2, 1, 0, and I'll write out my problem. 4, 8, negative 11, 3. And I will try positive 3 first. I'll bring down my 4. 3 times 4 is 12. 8 times 12 is 20. 3 times 20 is 60. Negative 11 plus 60 is positive 49, and clearly that one's not going to work. So we erase that. And we'll try again. Now I'll try positive 1. Again, I bring down the 4. 1 times 4 is 4. 4 plus 8 is 12. 1 times 12 is 12. Negative 11 plus positive 12 is 1. 1 times 1 is 1. Nope. I still have a remainder. So I'll go back. I'll erase that one. So I've tried positive 3 and positive 1. Now I'll try negative 3. Still bring down the 4. Negative 3 times 4 is negative 12. 8 plus negative 12 is negative 4. 3 times negative 4 is positive. Negative 3 times negative 4 is positive 12. Negative 11 plus 12 is 1. Negative 3 times 1 is negative 3. Now I have a remainder of 0. So this is one of my roots. So my factor that goes along with that would be x plus 3. Then I have 4x squared minus 4x plus 1. I'll do my x box. 4 times 1 is 4. And then my bottom number in my box is negative 4. So I know that I need two factors that multiply together to positive 4, but add together to negative 4. If they're going to multiply together to be positive, they both have to be negative. And then I'll sum. This one's negative 5. This one's negative 4. So that's the one I want. Negative 2 and negative 2. Now I'll write this out for grouping. 4x squared minus 2x plus 1. I'll group. My greatest common factor from the first group is 2x times x minus 1. For the second group, just the minus 1. That should be 2x minus 1 times 2x minus 1. So here I have 2x minus 1 is one of my factors. What's that being multiplied by? Well, 2x and minus 1. And then I don't want to forget the first factor I took out. So my fully factored form, f of x equals 2x minus 1 times 2x minus 1 times x plus 3. And then it says to find the zeros, not just find the factors. So I'll set each of these equal to 0. So 2x minus 1 equals 0, or 2x equals 1. So x equals 1/2. Same thing. It's a double root. And then x plus 3 must equal 0, so x must equal -3. So my three zeros are -3, 1/2, and 1/2. Problem number 3. Find all the zeros of the following function by using your graphing calculator first in order to find the rational zeros, then use the quadratic formula to get the irrational zeros. So first, I'm going to go ahead and I'm going to put this function into my calculator, which I have already done. 10x to the fourth minus 11x cubed, etc. Now I'm going to tell it to graph. I can see what my function looks like. I can see that there are 4 real zeros. But I don't know how many of those are rational and how many are irrational. So I tried looking in my table, and none of them show up, which means none of them cross at a whole number. So now I'm going to go ahead and use my calc function. And I'm going to find those zeros by using number 2, find zeros. So I'm going to move my cursor all the way to the left. I'll get started from the left side. And I'll work from left to right. So I'll set my first left bound to the left of my furthest to the left 0. Hit enter. Move my right bound to the other side of it. Hit enter, and then tell it to tell me what the 0 is. So this is x equals -1.56 and a whole bunch of stuff. That one is irrational. Moving forward and rightward, I'm going to find the next 0. So I'm going to move my cursor over to where it's to the left of that 0. Tell it that is my left bound. I'm going to move it to the right of that 0. Tell it that's my right bound and ask it to solve. Here I get x equals -0.5, or -1/2. That means that one of my factors is x plus 1/2, or more likely 2x plus 1. Let's find the next one. So once again, calc, 0, move my cursor over to be to the left, slightly to the left of the next 0, hit enter, move to the right of it, enter, and let the calculator guess, and it tells me my next 0, x equals 0.6. Well, these are rational numbers, so it's either 6/10 or 3/5. So my factor for that would be x minus 3/5, or more likely 5x minus 3. This one would have to be multiplied by 2. This one had to be multiplied by 5 to be able to do that. We'll keep moving forward. Now we'll take a look at that last 0. So I'll go back into my calc function. I'll choose 0. I'll move my cursor over so it's slightly to the left of where it crosses the x-axis. Hit enter, move it to the right, hit enter, and tell it to guess. And my next 0 is at x equals 2.56 and a whole bunch of other stuff, which is also irrational. Irrational numbers are those that cannot be expressed as a ratio. In other words, it is not a terminating or repeating decimal. These are non-terminating, non-repeating decimals, generally associated with square roots or pi or things like that. So let's take a look at those real roots we've already found. -1/2 and 3/5. So we're going to use our synthetic division to factor this. So I'm going to set up my coefficients 10, negative 11, negative 42, 7, and 12. I'm going to start with negative 1/2. I bring down my 10. Negative 1/2 times 10 is negative 5. Negative 11 plus negative 5 is negative 16. Negative 1/2 times negative 16 is positive 8. Negative 42 plus positive 8 is negative 34. Multiplication, that is positive 17. 7 plus 17 is 24. Multiplication, negative 1/2 times positive 24 is negative 12. And as hoped, 0 remainder. So this is one of my factors for sure, one of my zeros I should say. And then let's take a look at the next one, positive 3/5. So again, we'll take this part that's left over. We'll bring down the 10. 10 times 3/5 is 6, which leaves us with negative 10. Negative 10 times 3/5 is negative 6, which then leaves us with negative 40. Negative 40 times 3/5, negative 8 times 3, negative 24, no remainder, so also this is a good 0. Now, I now have 10x squared minus 10x minus 40. So I'm going to factor this. First, I'm going to take out the greatest common factor. So it becomes 10 times x squared minus 1 minus 4. Minus 1x, sorry, minus 4. So this 10 right here is where I needed my 2 and my 5 to be able to convert these into 2x plus 1, 5x minus 3. So now we'll take this and we'll solve it via the quadratic formula. So negative b, negative, negative 1. I'll go ahead and mark these as A, B, C. So negative, negative 1, plus and minus, square root of b squared. Negative 1 squared is 1. Minus 4 times A times C. Negative times a negative is positive. So I'll have 1 plus or minus the square root of positive 17 on top. And on the bottom, 2 times A is 2 times 1. So here I have positive 1. That's negative, negative. So that becomes a positive. Positive 1 plus or minus the square root of 17. All of that divided by 2. So once again, we're being asked to find the rational zeros. So my rational zeros are negative 1/2 and 3/5. And then we're asked to find the irrational zeros, which are 1 plus the square root of 17 over 2 and 1 minus the square root of 17 over 2. Moving on. Next page. Now we have some theorems. Here we have the complex conjugates theorem and the irrational conjugates theorem. So conjugates, as you'll recall, when we try to remove irrational numbers from the bottom of a fraction, we multiplied times its complex conjugate. So here, if a polynomial function with real coefficients has an imaginary zero of a plus bi, then a minus bi is also a zero for that function. Irrational conjugates, if a polynomial function with real coefficients has an irrational zero, then of a plus the square root of b, then a minus the square root of b must also be a zero. So we're going to write a polynomial function of the least degree that has the rational coefficients, the leading coefficient of 1, and the given zeros. So first, since these are the zeros, the factors are going to switch that sign. This means that x equals negative 1 or x plus 1 equals 0. Similarly, x minus 2 equals 0, x minus 4 equals 0. So we have three binomials. We'll put two of them together first. X squared plus 1x minus 2x minus 2. So we'll combine like terms of the x. So it becomes x squared minus x minus 2. Then we're going to multiply that by our third binomial. And we get x cubed minus 4x squared minus 1x squared plus 4x minus 2x plus 8. Now we're going to combine like terms. So I have x cubed minus 5x squared plus 2x plus 8. My next problem, 2 and 3i. Well, as we just said, if 3i or 0 plus 3i is one of my roots, then 0 minus 3i must also be a root. Again, a plus bi, a could be 0, which it is in this case. So now we're going to have x minus 2 times x minus 3i times x plus 3i. Now when I multiply, I'm going to do these two expressions together first. So that will give me x squared minus 3ix plus 3ix. They cancel. And then minus 9i squared. As a reminder, I squared is the square root of negative 1 squared, which is negative 1. Negative 9 times negative 1 is positive 9. And then I'll multiply all that times x minus 2. So when I do that, I get x cubed plus 9x. I left a little gap because I'm going to have minus 2x squared minus 18. And for each of these, we'd write these as f of x. Number 6, again, I have one of my irrational roots, so the other one must be its negative. Again, it's 0 plus the square root of 3, 0 minus the square root of 3. Number 7, we actually have one to work through. That one's a little more complicated. So here we have x minus 1 as a factor, x plus 2 as a factor, x minus the square root of 3 as a factor, and x plus the square root of 3 as a factor. I'm going to start on the right here and multiply these together. Again, those middle terms will go away. So I have x squared minus negative times a positive is a negative. Square root of 3 times the square root of 3 is 3. On the left, I have x squared plus x minus 2. I need to multiply these polynomials together. So x squared times x squared is x to the 4th. X squared times negative 3 is negative 3x squared. I'll keep working through. X cubed minus 3x, negative 2x squared plus 6. So the way I left these is so I can have nice columns to make sure I have x to the 4th term, x to the 3rd terms. I combine my x squared terms and work my way across. So f of x will equal x to the 4th plus x to the 3rd, etc., etc., etc. Moving forward, 3 plus I is a factor. Therefore, 3 minus I must also be a factor. But what does that really look like? That means x minus 3 plus I is a 0, equals 0. And x minus 3 minus I is a factor. Both times I'm subtracting, but what I'm subtracting has either 3 plus I or 3 minus I. So first I'll multiply these together, and then I also recognize my third root of negative 2 gives me a factor of x plus 2. So first, x times x, x squared. Well, let me go ahead and write these out. X minus 3 minus I, x minus 3 plus I, just so you understand where the negative signs are taking me. So just a touch more room here. So, the first part, x squared minus 3x plus ix. Next, minus 3x plus 9 minus 3I. Next, by negative I, minus ix plus 3I minus I squared. We'll simplify this before we try to multiply by the next binomial. So, what we recognize here, I have a positive ix and a negative ix. They'll cancel. I have a negative 3I and a positive 3I. They'll cancel. I have a negative I squared. I squared is negative 1. Negative negative 1 is plus 1. Now we'll combine like terms. X squared minus 6x plus 10. And now we will multiply that times our binomial x plus 2. X squared times x, x cubed. X squared times 2 plus 2x squared. Negative 6x times x minus 6x squared. Negative 6x times 2, negative 12x. Positive 10 times x plus 10x. Positive 10 times 2 plus 20. Combining like terms, I get x cubed minus 4x squared minus 2x plus 20, which is equal to my f of x. That is the end of day 8.